Assalamu alaikum, dear students. How are you? Hope all is fine. Here we have the continuation of the chapter 2 of AS Physics, and of course, you know that the chapter is Kinematics. Here we have another topic, as I said, this is the equations of motion. And whenever we are discussing kinematics, we have to consider certain parameters. Like, first of all, we should know that the most important is the displacement. We use S for displacement. You have U, the initial velocity. You will use V for final velocity of a body, of course, displacement of a body. You can write here as well. And this is same here, final velocity of a body. Then we have another aspect, which is T, the time to cover a displacement, or time to change the velocity. And A is the acceleration of a body. These are the terms, you can say, important terms here when we are going to discuss equations of motion. First of all, we have to consider one thing, that if a body moves from rest and after a time t moves with velocity v, then the displacement S we can write in the following way, or in the following equation, in the form of the following equation, in the following way, or in the following equation, whatever you want to write. S is equal to V bar T. Remember one thing, that here V bar is the average velocity. So whenever you will consider the V bar, basically this will be the average velocity. We will discuss this thing again, but for the time being, I'm just telling you that if a body is starting from rest and going to a particular value of velocity v, then how you will calculate the average velocity? So simply you can say that this is nothing but initial velocity plus final velocity divided by 2. So this is something which we can write. Or if the body is at rest, so of course at the initial state, the body is at rest or not moving with a certain velocity, so initial velocity is 0. So here you have the final velocity. So the average velocity you can write in this way. Then the final velocity divided by 2 will give you the numerical value of the average velocity. But of course you know that if you have point A, B, C, D and so on, then for each and every interval or displacement you have a particular velocity. So it may be, if the velocity is constant throughout, then the average value will be simple. But if it is changing, then of course you cannot, you can say, write, or you cannot calculate the average velocity easily. So always remember, this is a sort of technique or method that we are considering the initial velocity as zero velocity, and the final velocity, whatever the value we have. So average velocity you can find in this way, that v bar is equal to v divided by 2, yani final velocity divided by 2. So actually when you will discuss the graphs, then this is a very important concept, and you will see that how we are representing this in the form of the graph. So for the time being, this is your equation 1, and we are starting from this basic equation. Now as far as your first equation of motion is concerned, first equation of motion. So first equation of motion, how we can get this equation? We can start from the concept of acceleration. According to the definition of acceleration, we know that acceleration is equal to the rate of change of velocity. So if in one case, if, as I have already mentioned earlier, that if u is the initial velocity of a body, v is the final velocity of a body, then change of velocity will be equal to v minus u, and if this change of velocity occurs in time t, then we can write that acceleration is equal to a, and the acceleration is represented by a, and here we have rate of change of velocity. So change of velocity divided by time. So this will give you v minus u divided by t. So here you have the situation, a is equal to v minus u divided by t, or what we can do, simply we can say AT is equal to v minus u. So if you are writing v is equal to u plus AT, this is nothing but the first equation of motion. This is the first equation of motion. Okay, so this is important. The above equation is termed as first equation of motion. Fine. So this is very important, that how you can get, or how you can develop first equation of motion. So these are few steps, very simple steps, and you can very easily get this value or this equation v is equal to u plus at. Here you have to remember that out of these quantities, the s, the displacement, is missing in this equation. So if you have any problem where s is not involved, initial velocity, acceleration and time suppose are given, and you need to calculate the final velocity, so you can use this equation. Similarly, if final velocity and say acceleration and time is given, so you can calculate the initial velocity and so on. So out of these four parameters or four quantities, three quantities will be given and fourth you have to calculate, so you can use this equation, which is the first equation of motion. Now we are going to the second equation of motion. Second equation of motion. Here we will start from the concept of our basic equation, and here I am writing in this way that we know that for displacement s with an average velocity during time t, we have the following equation, as we have discussed already, that s is equal to v bar t. So here this is our first equation or initial equation, you can say. Now, as I have already told you that v bar is nothing but u plus v divided by 2, yani you have started with an initial velocity and you have moved to a particular value which is the final velocity, so we are getting the average velocity in this way. So what we can do now, by say suppose this is our equation A in this case, now by using equation A in equation 1, we get what we get, that s is equal to u plus v divided by 2 into t. So for the reference we are considering this as equation 2. Now we also know that v is equal to u plus at. We have just you can say drive this equation, which is the first equation of motion. Even you can write here that we know according to the first equation of motion, v is equal to u plus at. Here I am just taking this for reference b. Now by using equation b in equation 2, we have what we have, s is equal to u plus, now you know that here you have this v and we are just putting the value of v or equation for v here, and what is this situation, u plus at, this is for, remember this thing, this is for v, so instead of v we have written u plus at, so be careful. So here divided by 2 you already have, and of course this t is already present. So what you can write now, here you have u and u, so 2u plus AT is still in the bracket. So this is what we have. And then we can write S is equal to 2U divided by 2 plus AT divided by 2 into T, and ultimately what you are getting, U plus AT, and here you have T. When you will simplify the above equation, you are getting UT plus half AT square, and this equation is nothing but the second equation of motion. Now remember, as I just have discussed this point, that this is the second equation of motion, and I can write here in this way that the above equation is termed as second equation of motion. Here another point is that in the above equation, and in the second equation of motion, you can say the final velocity V is missing. So if you have any situation where the final velocity is not given, the initial velocity is given, the time of change of velocity is given, and the acceleration value is given, then you can calculate or you can find the displacement with the help of this second equation of motion. So this is something which is very important, that this is second equation of motion, and you will use this equation when the final velocity is missing from the data. Any information of the final velocity is not present in any case. So, and you want to calculate the displacement, in that case you will use the second equation of motion. I hope you have understood this thing. If you have any problem, you can ask in the comments. Then I am moving to the third equation of motion, and here I am writing third equation of motion. For third equation of motion, we will start from the concept of acceleration and of course the you can say time. What we have here, according to the definition of acceleration, A, we have the following equation. You already know that A is equal to V minus U divided by T. Now if we want to write this equation you can say making T as a subject, then V minus U divided by A will be the new form of the equation, and I am considering this here as equation 1, suppose. And when we have the average velocity V bar, now we have the average velocity V bar in the following equation. V bar is equal to U plus v divided by 2. We have already discussed this average velocity thing, so I am just taking directly this equation. Now the point is, now we also know that S is equal to V bar into T, and by using equation 1 and equation 2, in the above equation, suppose we are considering this as 3, so we can write here 3, we get, what we get, S is equal to V bar U plus V divided by 2, and for this T here, for this T, what we can write, what we can use, equation 1. So simply we have nothing but V minus U divided by A. Little change in the order, we can write in this way, V plus U, as such there is no change, but just an order. And here you have this situation that the S is equal to V plus U divided by 2, and here you have V minus U divided by A for T, and this is for average velocity. Now a little change in the order, and what you can write, 2AS is equal to V plus U, V minus U. And you know that when you are considering, suppose this formula here, you have this formula, you already know that A plus B into A minus B. So what you have, A whole square minus B whole square, or simply A square minus B square. So same is the formula you can use here. So you can write V whole square minus U whole square, and ultimately 2AS is equal to V square minus U square. Or in few books you will see that they are giving you the above equation in this way, that V square is equal to U square plus 2AS. So both of these equations you can use, whether you are using this equation here or you are using the equation V square is equal to U square plus 2AS. Both these equations are basically the third equation of motions. I mean, only the form is changed, but both of these equations are third equation of motion. Here you will see, first of all, we can mention this thing, that the above equation is termed as third equation of motion. This is one simple thing. The second point you can mention is that here your time t is missing. Thus, if we have to calculate, here we have to calculate suppose the displacement and V and U and accelerations are given, then we can use the above equation or third equation of motion. So this is what we have as far as the third equation of motion is concerned. So simply you can say that these are few equations which we have to remember. One is S is equal to V. This is a very basic equation. Set the V is equal to U plus AT is the first equation of motion. S is equal to UT plus half AT square. This is the second equation of motion. And 2AS is equal to V square minus U square. This will be your third equation of motion. So remember this thing, that whenever you will use the concept of mechanics and you have to calculate displacement or time or acceleration, whatever, you will use either of these four equations. But remember this point, that here there is no change in acceleration. So that's why in the very beginning of this discussion, I have already mentioned that this discussion is for uniformly accelerated bodies. So this is something which is very important. So inshallah, when we will come to other you can say topics, we have to use these equations. So of course you have to go through these equations and remember these equations. If you have any problem, you can kindly ask through the comments and I will give you answers. But if you are new on this channel, so subscribe this channel and share this channel, like this channel, and press the bell icon as well, so you can get the new uploaded videos. And if you will be regular for these you can say lectures, inshallah you will not feel any difficulty as far as the completion of your AS physics is concerned. Of course, we are uploading A2 physics as well. So if you have any friends in A2, you can also ask them to join here, and they will also get all the lectures and all the lectures of all the topics, inshallah. So this is how we are doing here. We want to help you people, and actually nobody can help you if you will not help yourself. So this is very, very important. I have been mentioning this thing, that in A level your self study is the most important thing. Nobody can force you to sit. If you will sit and take interest in the subject, whatever the subject is, no subject is difficult, but every subject is difficult if you are not giving proper time. So this is very important. Whatever the college you are in, or who is the teacher in your college, this is not important. The important point is that whether you are taking interest or not. So come out of the I always use this thing, come out of the O level attitude and try to be more serious, more maturity you have to show, and inshallah you can do it. So good luck for your rest of the syllabus, and be on my channel, follow the channel, follow these videos, and inshallah you will not feel any difficulty in the 9702 course. We will solve the past paper questions here as well. So just try to follow, and inshallah you will get good result. So good luck, and be careful, take care. Allah Hafiz.